Okay, let's start with the basics. A full-stack developer is someone who can handle almost any part of building a website or web application from what you see and interact with on the screen to all the complex processes happening behind the scenes. They're like a one-stop shop for development, which makes them really valuable in teams. Okay, let's talk about what a full-stack developer actually does. Basically, they're the wizards behind the web. They tackle both the parts you see, the front end, like the design and how things look on your screen, and the back end, which is all the servers and databases working hard behind the scenes. They often work with languages like Python or JavaScript, building the logic that powers everything. And it's not just coding, they're also responsible for managing databases, making sure everything connects through API, testing their code to catch any bugs, and generally keeping the whole web application running smoothly. Okay, let's talk about how websites work. It all starts with something called client-server architecture. Basically, you have two main players: a client that's your browser or app, like Chrome or Instagram, and a server. The client is what you actually use. It sends requests, like, hey, show me the homepage. The server is where all the data lives and gets processed. It's like Google's computers working hard to send you the website you asked for. They talk to each other using something called HTTP. Think of it as their secret language. Okay, let's talk about how a full-stack developer thinks about building applications, specifically the difference between the front end and the back end. The front end is all about what you see and interact with. It's the visual part of your website or app, built using languages like HTML, CSS, and JavaScript. It's responsible for creating a great user experience. On the other side, we have the back end. This handles everything that's going on behind the scenes. Think of it as the engine powering the application. It manages data, handles security, and makes sure all the pieces work together seamlessly. As a full-stack developer, you'll need to understand both sides of this equation to truly build complete solutions. Okay, let's dive into HTML5 and how it's changed the game for web development. HTML5 is basically the newest version of the language we use to build websites, bringing some really cool new features. It's all about making things more structured. Think of it like giving your website a clear skeleton. We have new elements like which help tell browsers and screen readers what each part of the page is actually doing. Beyond that, HTML5 has built-in support for audio and video, making it easier to integrate multimedia content. And if you're interested in creating interactive graphics or games, take a look at the Canvas API. Finally, semantic markup is super important. Using these proper tags isn't just about making your code look nice, but also helps make it easier for developers to understand and maintain. Okay, let's dive into CSS3. It's your foundation for styling anything you build as a full-stack developer. We'll start with the basics, understanding how to select elements and control their properties using CSS3 features. Then we'll tackle flexbooks, which is super useful for one-dimensional layouts, making it easy to align things horizontally or vertically. Next up is CSS Grid, perfect for those more complex two-dimensional designs. And finally, let's add some flair with animations and transitions. They can really elevate the user experience of your web apps. Okay, let's talk about making sure your website looks amazing on every device. We're going to focus on responsive design and media queries. They are essential for a great user experience. Responsive design is all about creating websites that automatically adjust their layout based on the screen size of the device being used. Instead of building separate, complicated layouts for desktops, tablets, and phones, we use flexible grids and images. The real magic happens with media queries. These are CSS rules that let us apply different styles depending on things like screen width. Think about it: when a website is too wide for a phone screen, you want the elements to stack vertically, right? Media queries allow us to do exactly that. The example code shows how we can use a breakpoint of 768 to stack elements instead of floating them side by side. Experimenting with different breakpoints and CSS properties is key to mastering responsive design. Okay, let's talk about how full-stack developers make websites interactive. We're going to focus on the DOM and event handling. The DOM is basically a tree-like representation of your HTML code. Think of it as the blueprint for your website. DOM manipulation allows us to change the blueprint dynamically with JavaScript, so we can update content without needing a full page reload. We use methods like getting elements by ID or using CSS selectors to find what we want to work with. Then we change things directly, like updating the HTML content or the text itself. And when users interact clicking buttons, moving their mouse, that's where event handling comes in. We attach functions called listeners to those interactive elements so our code can respond to those actions and do something cool. Okay, let's talk about the synchronous JavaScript. Because our web apps need to be responsive, we can't just wait for things like API calls to finish. That would freeze the whole interface. So we use promises. They represent future values or results of an operation. Think of them as I'll let you know when this is done. They have 3 states: pending, fulfilled, and rejected. Then async/await comes along, making asynchronous code easier to read and write by looking more like regular synchronous code. Okay, let's dive into the popular choices for building user interfaces: React, Vue, JS, and Angular. These frameworks make front-end development much more efficient. We'll look at each one briefly. React is known for its component-based approach and a virtual DOM which makes updates super fast. Vue.js is really great if you're starting out or want something easy to learn, while Angular offers a complete solution especially suited for larger projects with teams that are comfortable with TypeScript. Ultimately, the best choice depends on your specific project's needs and what works best for your team. Let's talk about how components are the heart of modern front-end development. Component-based architecture, or CBA, is all about building your user interface from smaller, reusable pieces just like Lego bricks. This approach makes it much easier to maintain and update your application over time. Components can be used again and again, reducing code duplication and simplifying debugging. They also allow you to test each piece in isolation, which improves overall quality. Think of props as information passed asterisk into asterisk, a component like the user's name or age. And state is data that changes within the component itself. It's how things get dynamic. Okay, let's talk about React hooks. Specifically, we're focusing on useState, useEffect, and useContext. useState is fantastic for managing simple pieces of data directly within your component. Think of it as a way to create variables that automatically trigger updates when changed. Then there's useEffect, which lets you handle side effects like fetching data or setting up subscriptions, all without the complexities of class components. Finally, we have useContext, perfect for sharing global state throughout your application. Think themes or user preferences and avoiding prop drilling. Okay, let's talk about routing in front-end applications. Think of routing like the table of contents for your website. It allows users to easily jump between different sections without having to refresh the entire page. We'll look at 2 popular libraries, React Router and Vue Router. Both are designed to handle navigation on the client side, updating the URL, and then rendering the correct component to show the user what they're seeing. React Router uses JuiceNavigate for programmatic routing, while Vue Router utilizes Router Push, which is super convenient within a Vue app. Understanding these basics will be key as you build more complex single-page applications. Okay, let's talk about state management, a really important part of building full-stack apps. Essentially, it's about how we handle data throughout the application. We have a few popular tools for this, like Redux, which is great for bigger projects where you want really organized state flow. Then there's React's Context API, which is super useful when you need to share data between components without having to pass it down through every level of your component tree. Think of it as a convenient way to distribute information. Finally, Vue is a similar tool, specifically designed for Vue.js applications and often considered easier to learn than Redux if you're already using Vue. Okay, let's talk about single-page applications or SPAs. Basically, they're a modern approach to building web apps. Instead of your browser constantly requesting entirely new pages every time you click something, an SPA updates the content on the *same* page using JavaScript. It's like Gmail or Google Maps. It feels like one continuous experience. This means things load faster and generally provide a smoother, more responsive feel for the user, and less work for your server. Okay, let's talk about PWA. Think of them as websites that are super smart and can almost act like native apps you download from an app store. The cool thing is they provide a really great experience for users because they work offline. You can easily add them to your home screen, and even get push notifications just like a real app. They achieve this through two key technologies: service workers, which are like background workers that handle things like caching and network requests, and the web app manifest, which is basically an instruction manual for how the browser should display the PWA. Okay, so let's talk about making your websites load faster and feel snappier. Front-end performance optimization. As a full-stack developer, you're not just building the features, you also need to ensure they run smoothly for users. A slow website can really frustrate visitors and make them leave. The good news is there are lots of things we can do. We'll start by reducing the number of requests our browser has to make. Think combining CSS and JavaScript files, or using techniques like CSS sprites. Then, it's about optimizing images, making sure they're in the right format and compressed properly. Browser caching is also key, letting browsers store assets so they don't have to download them every time. We can minify our code too, reducing file sizes. And finally, lazy loading, only loading things when they are visible on the screen. Tools like Lighthouse and Page Speed Insights can really help you pinpoint where improvements can be made. Okay, let's talk about Git. It's absolutely crucial for any full-stack developer. Think of Git as your project's time machine and collaboration tool all rolled into one. It allows you to keep track of every change you make to your code, so if something goes wrong or you need to revert to an earlier version, you can easily do so. We'll cover some key terms like repositories, commits, branches, and merges. These are the building blocks of how Git works. You'll clone a repository from somewhere like GitHub, then add changes, commit them with helpful messages, and finally push those changes up to a remote server. It might seem a little daunting at first, but trust me, it gets easier with practice. Okay, let's talk about branching. It's a super important part of being a full-stack developer and keeping code organized. We have two common approaches, Git Flow and GitHub Flow. Git Flow is like a detailed roadmap. It has specific branches for features, releases, and fixes. Think of main as the stable base, and you'd create feature branches off of that for new additions. GitHub Flow is much simpler. It's all about small, frequent pushes and pull requests directly into your main branch. Basically, you just keep pushing updates until they're reviewed and merged. Both are valuable. Git Flow can be really helpful for large projects with complex release cycles, while GitHub Flow works great for smaller teams wanting a faster pace. Okay, let's talk about package managers. They are absolutely essential for any full-stack developer. Think of them as the organizers of your project, making sure you have all the right tools and libraries to build something amazing. We've got a few popular ones: npm, yarn, and pnpm. npm is super common because it's the default for Node.js. Yarn is really focused on speed and reliability. And pnpm is a newer option that's gaining traction for its simplicity. Basically, they handle installing, updating, and removing all those external components your project needs. Okay, let's talk about REST-file API. They're a really important part of building modern web applications. Think of them as the backbone of your backend. REST stands for Representational State Transfer, and it's not a specific technology, but rather a set of guidelines. It's all about how we design networked apps, keeping things organized and efficient. The key is to have a clear separation between the client, like your website or app, and the server that handles the data. Also, each request should be stateless, meaning the server doesn't remember anything from previous requests. We want caching so everything loads faster, and a uniform interface using standard HTTP methods makes things predictable. Let's look at some of those common methods. Get retrieves data, post creates new data, put replaces existing data entirely, patch updates parts of it, and delete removes items. Mastering these principles is absolutely key for any full-stack developer. Okay, let's talk about GraphQL. It's a really powerful tool that can make building web applications much easier and faster. Basically, it's an alternative to the traditional REST approach. With REST, you often get more data than you actually need. This is called overfetching. Or sometimes you don't get enough, leading to underfetching. GraphQL solves these problems by allowing your client, like a website or app, to precisely request only the data it needs from the server. It's like ordering exactly what you want from a menu instead of getting a preset meal. It uses an explicit schema so that both the front-end and back-end developers have a clear understanding of available data. Let's quickly look at how it works. A client sends a query, and the server responds with precisely the data requested. Think of it as a very targeted data retrieval system. We'll also compare it to REST to see how different they are. It can seem complex initially, but trust me, once you get the hang of it, it's incredibly efficient. Okay, let's talk about keeping your full-stack apps safe. We're focusing on API authentication today and looking at two really important tools, JWT and OAuth 2.0. JWT are like digital passports. They carry essential user information in a secure format. Think of them as self-contained tokens. Then there's OAuth 2.0, which is all about giving third-party apps permission to access data on behalf of users without needing their passwords directly. It's a smart way to manage access control. We'll look at the basic idea behind JWT creation, and then a simplified overview of how OAuth 2.0 works, essentially authorizing an app to act for you. Okay, let's talk about testing API. We're going to look at two really great tools for the job, Postman and Swagger. Postman is like a super helpful client that lets you send requests to your API and see exactly what comes back. It's really intuitive. Then we have Swagger, which is all about documenting your API in a standard way. When an API is documented with Swagger, tools like Postman can automatically generate the requests for you. Think of it as having a built-in guide. We've got a quick table here comparing some key features to give you a better idea. Okay, let's talk about CORS. It stands for Cross-Origin Resource Sharing, and it's a really important security feature in web development. Basically, a website can only access resources from the same domain as itself. Like, if you're building a site on example.com, you generally can't just jump over to another website and grab data directly. CORS is how browsers prevent that kind of unauthorized access. It's like a security guard making sure only authorized requests get through. When you try to fetch data from a different domain, let's say an API hosted on API example.com, the browser checks if that server has explicitly allowed your origin example.com to access its resources. If it hasn't, you'll see an error and the request won't go through. It's all about protecting API from being misused. Okay, let's dive into backend frameworks. These are the tools that power the server-side logic of your full-stack apps. We've got a few really popular choices. Express.js, which is super lightweight and great for quick development using JavaScript. Django, a robust Python framework designed to speed up complex project building. Flask, a smaller, more flexible option perfect for projects where you want maximum control. And finally, Spring Boot, a Java powerhouse that makes working with the Spring ecosystem much easier. Let's talk about databases. They're absolutely essential for any full-stack developer. Think of them as the brains behind your application, storing all your information. We have two main types: SQL databases, which are really structured and great for things like e-commerce, where you need to ensure everything is perfectly consistent. Then we have NoSQL databases, which are more flexible and often used when speed and scalability are key, like with social media apps. There's a lot of different kinds within NoSQL too, from document stores to graph databases, so understanding the right one for your project is important. Okay, let's talk about databases. As full-stack developers, we need to be comfortable working with them. We're going to focus on three big players: PostgreSQL, MySQL, and MS SQL Server. PostgreSQL is really powerful and flexible. It's a great option when you have more complicated projects or want something super reliable. MySQL is incredibly popular and easy to use, especially for web applications. It tends to be very performant. And finally, we have MS SQL Server, which integrates seamlessly with Microsoft technologies like it. So think about your project requirements. What are you building and how complex is it when making your database decision? Okay, so let's talk about NoSQL databases. They are a really important tool for full-stack developers today. Relational databases are solid, but NoSQL provides more flexibility and can handle different kinds of data much better. We have three main contenders: MongoDB, Redis, and Cassandra. MongoDB is like storing your data in JSON files, super easy to work with if you're building something quickly. Then there's Redis, which acts like a really fast memory bank for your app. It's fantastic for things like caching or managing user sessions. And finally, Cassandra is built to handle massive amounts of data and keep everything running smoothly even when the load gets huge. Think about apps with millions of users. Okay, let's talk about ORM. Think of them as translators between your code and the database. They let you work with data in a much more intuitive way, like using objects instead of raw SQL queries. We've got some really popular options out there. SQLize is a great choice for Node.js projects, offering features like migrations to manage database changes smoothly. SQL Alchemy is super flexible and powerful, especially for Python developers. And Prisma is newer, but gaining serious traction because it takes a database-first approach, making things even more type-safe and easier to work with. Okay, let's talk about optimizing our databases. As full-stack developers, we need to make sure our applications are fast, and that starts with how efficiently we're retrieving data. Indexes are key here. Think of them like an index in a book. They allow the database to quickly locate specific information without having to check every single row. We've got clustered indexes, which physically order the data, and non-clustered indexes, which point to the actual data records. It's really important to understand how your queries are being executed. Use query execution plans. And when writing queries, only select the columns you truly need. Avoid select asterisk, it can really slow things down. Plus, optimizing those where clauses and using efficient joins will make a huge difference. Okay, let's talk about how we can speed things up in our full-stack applications. First up is memory caching. Think of it as a super fast little notebook where the app keeps frequently used data. It's great for small amounts of information that change often. Next, we have Redis, which is like a more powerful and sophisticated cache that also offers persistence, meaning it remembers things even if the server restarts. Finally, we have CDN. These are networks of servers all over the world that store copies of your static assets like images and scripts, so users get them from the closest location, drastically reducing load times. Let's talk about keeping users safe and logged in. Session management. Think of it as the backend's way of saying, hey, we remember who you are. It's all about securely tracking a user through your application from page to page. We use something called a session ID, often stored in a cookie, to link the browser back to the server. There are different ways to do this: the classic cookie-based approach and newer, more secure methods like using JSON Web Tokens or JWTs, which are great for scalability. Okay, let's talk about handling files, a really common task for full-stack developers. When you need to let users upload things like images or documents, there are a few crucial steps we have to get right. First and foremost, security is key. We absolutely must validate the file type, size, and even check its content to make sure it's safe. Then, we need to decide where to store these files. That could be something like cloud storage or maybe a local server. We also want to do validation on both the front end with our website code and on the back end as well, just to double check everything is good. And finally, don't forget about handling errors gracefully. If an upload fails, you need to let the user know. It's a fairly standard workflow. The user uploads to a form, the server receives it, validates it, and then saves it somewhere safe before sending back a link or some information about where they can find their file. Okay, let's talk about asynchronous backend programming. It's a really important concept for full-stack developers. Essentially, instead of waiting around and blocking our code while we're getting data back from something like a database or an external API, we can handle multiple requests at the same time. This makes things much more responsive, especially when you have lots of users hitting your application at once. We'll cover why this is so beneficial: improved responsiveness, better scalability, and overall greater efficiency. We'll look at some key techniques like callbacks, promises in JavaScript, and async/await, which really simplify working with asynchronous operations. Okay, so let's talk about microservices. Think of a huge, monolithic application. It can be really tricky to manage and scale. Microservices are all about breaking that down into smaller, independent pieces. Each service focuses on doing one thing well, like managing products, handling orders, or processing payments. The great thing is you can deploy these services separately, scaling only what needs the extra power. And if one service has an issue, it's less likely to bring everything else crashing down. That's a big win for reliability. Okay, let's talk about how different parts of an application are built. We often hear about architectural styles, and today we're comparing three major ones: monolithic, microservices, and serverless. A monolithic architecture is like a giant block. Everything lives together in one place. It's simpler to start with, but as your app grows, it can become really hard to scale and update. Next up are microservices. Think of them as smaller, independent teams working on different parts of the same application. Each team can work more independently, making development faster. But this also brings in its own set of challenges around connecting everything properly. Finally, we have serverless. This is where you're not worrying about managing servers at all. You just write small pieces of code that run when needed and only pay for what you use. It's great for unpredictable workloads, but there can be some complexities to work through. Ultimately, the best choice depends on your project. Okay, let's talk about how messages and events are changing the way full-stack apps work. Instead of components constantly talking to each other directly, which can get really messy, we use message queues. Think of these as buffers where data sits until something is ready to process it. An event-driven architecture means our applications react to things happening like a user clicking a button rather than always waiting for another component to respond. We've got two popular players in this space: RabbitMQ, which is super flexible and reliable, and Kafka, which is really great at handling huge amounts of data in real time. Okay, so let's talk about service discovery and API gateways. These are crucial components in building modern, scalable applications, especially with microservices. Think of service discovery as a digital phone book for your services. It allows different parts of your application to find each other without needing hard-coded addresses. And an API gateway. That's the central point of contact for all incoming requests from clients. It smartly routes those requests to the exact backend service that needs them, handling things like security and authentication along the way. They really work together to make your system more flexible, resilient, and easier to manage. Okay, let's talk about WebSockets. They're a crucial technology for building really dynamic and responsive web applications. Basically, instead of the client constantly asking the server for updates like with traditional HTTP, WebSockets create a persistent connection. It's like a dedicated, always-on highway between your website and the server. This allows data to flow in both directions instantly, which is perfect for things like real-time chat or collaborative tools where everyone needs to see changes as they happen. Let's dive into Docker and containerization. They are really key for full-stack developers. Essentially, a container is like a self-contained package that includes everything your application needs to run: code, libraries, dependencies, everything. This makes sure your app behaves the same way whether you're testing it locally, deploying it on a server, or moving it around. The main advantage here is consistency. No more "it works on my machine" problems. Plus, containers are super portable. You can move them easily between different servers. And because they use fewer resources than traditional virtual machines, you get better efficiency. Finally, the isolation aspect offers a layer of security and prevents things from interfering with each other. Okay, so let's talk about Kubernetes. It's essentially a system that helps you manage your applications when they're running in containers. Think of it like a super efficient traffic controller for those containers, making sure everything is where it needs to be and working smoothly together. At its core, A pod is the smallest unit, usually just one container. Deployments are what keep track of how many copies you want running, and services give your application a stable address so people can always find it. Let's talk about CI/CD. It's all about making the development process smoother and more reliable. Basically, continuous integration means we're constantly merging our code changes into a central spot and automatically running tests to catch any problems early on. Then, continuous delivery or deployment is about automating that release process, so when something new is ready, it's just waiting for approval and can be deployed quickly. We use tools like Git for version control, CI/CD platforms like Jenkins or GitHub Actions, and lots of automated testing to make sure everything works correctly. A typical pipeline involves code commits triggering builds and tests, followed by deployments to staging environments where stakeholders can give the thumbs up before it goes live in production. Okay, let's talk about infrastructure as code, a really important concept for full-stack developers. Basically, instead of manually setting up servers and networks, we use code to define our infrastructure. This makes things much more reliable and easier to repeat. We'll look at two popular tools, Terraform and CloudFormation. Terraform is super flexible because it can work with many different cloud providers like AWS, Azure, or Google Cloud. It uses its own language called HCL, which can seem a bit different at first, but it's very powerful. CloudFormation is specifically for Amazon Web Services and uses YAML or JSON to define your infrastructure. There are some key differences between them, particularly around multi-cloud support and state management. We'll take a quick look at a table that highlights those contrasts. Ultimately, both tools help us automate our infrastructure, which means less time on tedious tasks and more time building awesome applications. Okay, let's talk about cloud platforms. They are absolutely essential for any modern full-stack developer. Think of them as the foundation on which your applications are built. We've got three major players: Oz, Azure, and GCP. AWS is the most established, with a huge selection of services. Azure really shines if you're already using Microsoft products like Windows Server or .NET. And GCP? It's often at the cutting edge, especially when it comes to data analytics and artificial intelligence. Each platform offers different strengths, so understanding these differences will help you choose the best one for your specific project. Okay, let's talk about serverless functions. These are really cool pieces of code that just run when they're needed, no need to manage servers yourself. They scale automatically as demand goes up and you only pay for the time they actually run. Think of them like tiny little apps that respond to events, such as an HTTP request, making them incredibly efficient. AWS Lambda is a popular choice, offering great integration with other services. Google Cloud Functions is a comparable option too. You can see a simple example here. It just takes in some input and returns a response. Hey everyone, let's talk about keeping our full stack apps safe. Security isn't just an afterthought, it's a fundamental part of the development process. We need to think about how we handle user input, make sure people are who they say they are, protect sensitive data, and keep all our tools up to date. Specifically, validating what users enter is super important. No one wants SQL injection or cross-site scripting attack on their hands. Then strong authentication and authorization. Think multi-factor login will really boost your security posture. Don't forget about securely storing data. Encryption is key. And finally, always keep an eye on those third-party libraries we use. They can be a source of vulnerabilities if we don't update them regularly. Okay, let's talk about keeping your web app safe. When you're building a full-stack application, you'll be dealing with user input all the time. That means we need to make sure that data is actually what it should be and doesn't contain anything harmful. We do this through two key steps: validation and sanitization. Validation is essentially checking if the input meets our expectations, like making sure something is in the right format or within a certain range. Sanitization goes further by removing or escaping potentially dangerous characters. Think of it as cleaning up the data to make it safe for your application to use. There are several ways to do this, from server-side checks to client-side feedback, and even using regular expressions for complex format validation. Always prioritize server-side validation. That's where you need to be sure things are secure. Okay, let's talk about keeping our web applications secure. Specifically, we're diving into cross-site scripting and cross-site request forgery, two common threats that full-stack developers need to be aware of. XSS is all about injecting malicious scripts onto a website, tricking users into running them. It can lead to serious problems like stolen information or account hijacking. There are different types, like reflected XSS where the script bounces back, and stored XSS where it's saved on the server. Then we have CSRF. Think of it as tricking someone's browser into making requests they didn't intend to make, often when they are already logged in somewhere. It's a really clever attack. To combat these, we use techniques like careful input validation, encoding data properly before displaying it on the page, and setting up something called content security policy. And for CSRF, things like same-site cookies and CSRF tokens can make it much harder to pull off. Okay, so let's talk about keeping user passwords safe. It's really important to never store them in plain text. That would be incredibly risky. We can use hashing and salting to make this much more secure. Hashing is a one-way process. It turns your password into an unrecoverable string of characters, like a unique fingerprint. And salting adds a random element, a little secret extra to each password before we hash it. This makes rainbow table attacks where attackers use pre-computed hashes essentially useless because they need the specific salt for each user. We'll use libraries like bcrypt to handle all this securely and efficiently. Okay, let's dive into making our web apps more secure by focusing on something really important: security headers and HTTPS. Basically, HTTPS encrypts all the data traveling between a user's browser and our website, protecting everything from passwords to credit card numbers. Now, there are these handy things called security headers that tell browsers how to behave when they visit our site. We've got content security policy, which is like a whitelist for resources. Strict transport security forces HTTPS connections, and X-frame options helps prevent clickjacking. Then we have X content type options, which helps stop some sneaky tricks. To actually get these headers working, you'll need to configure your web server, things like Apache or Nginx, and make sure your content delivery network or CDN also supports HTTPS. Finally, it's super important to test everything using a handy online tool to double check that the headers are set up correctly. Security is something we always have to be thinking about, so remember to keep your software updated and check those configurations regularly. Okay, let's talk about front-end testing. As a full-stack developer, you need to make sure your user interface is working correctly. We're going to cover 3 fantastic tools: Jest, React Testing Library, and Cypress. Jest is a super popular JavaScript testing framework that's really fast and easy to use, especially with React. React Testing Library focuses on how users actually interact with your components, simulating those actions rather than diving into implementation details. And finally, Cypress allows you to test the entire application flow from start to finish, giving you powerful debugging tools. Okay, let's talk about backend testing. It's a really important part of building solid full-stack applications, often just as crucial as what we see on the screen. We'll be looking at a few popular frameworks that help us test our backends: Mocha for JavaScript to try to make assertions easier, JUnit if you're working with Java, and PyTest for Python developers. Each of these provides tools to verify your code is doing what it's supposed to do, ensuring data is correct and everything runs smoothly. Okay, so after you've built your awesome front-end and back-end pieces, it's super important to make sure they actually talk to each other. That's where integration testing comes in. Think of it as checking the wiring between different parts of your application. Then we move on to end-to-end (ETOE) tests, which are like simulating a user going through their entire workflow from starting a session all the way through to completing an action. Tools like Cypress and Playwright can really help you automate these real-world scenarios. Don't forget about API testing with tools like Postman too. Okay, let's talk about web performance optimization. It's a big asterisk deal for any full-stack developer. Basically, you want your websites to load as fast as possible. A slow website can really frustrate users and hurt how well your site ranks in search results. There are three key areas we need to consider: the front end, which is what people see directly; the back end, where all the data processing happens; and the network itself. On the front end, things like reducing the number of images you're using, making sure they compress properly, and minimizing your CSS and JavaScript files are really important. Then on the back end, efficient database queries and caching can make a huge difference. And finally, using a CDN to distribute your content across multiple servers can speed up loading times for users around the world. Okay, let's talk about getting your single-page applications visible in search results. SB8 can be tricky from an SEO perspective because they rely heavily on JavaScript. The good news is there are some really effective strategies we can use. First off, consider using server-side rendering frameworks like Next.js and Next.js let you render the initial HTML before sending it to the browser, which makes everything much easier for search engines to understand. Pre-rendering is another option. It's a manual process of generating static versions of key routes. Dynamic rendering helps too, by using tools to create static HTML copies. Don't forget about standard SEO elements like meta descriptions and titles, and most importantly, use schema markup to give search engines context. Finally, make sure your robots.txt file is set up correctly to guide crawling. It's a continuous effort, so keep an eye on performance and adjust your approach as you go. Let's talk about making websites accessible for everyone, especially those using screen readers. Area is a set of attributes that give assistive technologies like screen readers more information about the purpose and function of elements on your page. Think of it as providing extra context. WCAG guidelines often recommend using Area to ensure proper keyboard navigation. This means users can easily move through your website with just their tabs and arrow keys. Area roles are essentially categories for interactive elements like buttons or menus. There are different roles you can apply, and we'll see examples of how they work in code. Don't forget attributes like area label to give a clear description, area describe to link to helpful information, and area hidden. Use this carefully to avoid overwhelming screen readers with unnecessary details. Let's talk about how Fullstack developers can boost their apps by using browser storage. We're going to look at three main types: local storage, session storage, and IndexedDB. Local storage is like a little notebook that keeps data even when you close your browser tab, perfect for remembering user preferences or settings. Session storage only lasts while the current session's open. Once you close it, everything disappears. And finally, IndexedDB. That's essentially a mini database within your browser, ideal for storing and managing really large amounts of data efficiently. Okay, so let's talk about API, specifically the difference between stateful and stateless ones. Think of a stateful API like a conversation where you remember everything that's been said before. Authentication systems are a great example. They keep track of your session. That works well for users, but can be tricky to build on at scale because everything is tied together. Now, a stateless API treats each request as completely new, no matter what happened in previous requests. RESTful API, those using methods like get and post, are the classic example. They're fantastic for scalability because they don't rely on maintaining any client-side information. It's all self-contained. Essentially, stateless is generally preferred for building robust and scalable web applications. Okay, let's dive into reverse proxies and load balancing, super important tools for any full-stack developer. Think of a reverse proxy as a gatekeeper in front of your application servers. It handles all the incoming requests before they reach the actual backend. This protects your servers from direct exposure and adds a layer of security. It can also cache frequently accessed content, making things faster for users. Now, load balancing is about distributing that traffic across multiple servers. Imagine you have 5 web servers. Load balancing ensures no one server gets overwhelmed, keeping everything running smoothly and reliably. There are different algorithms to decide how traffic gets distributed, like rotating through them or sending more traffic to the server with fewer active connections. Okay, let's talk about database migrations, a crucial part of any full-stack project. When you're changing databases or upgrading your schema, you need a solid strategy. There are a few common approaches. First up is schema migration tools like Flyway and Liquibase. These let you define changes to your database structure in versioned files, making sure everything stays consistent across deployments. Then there's the classic dump and restore method, exporting data into a file and importing it into the new database. This can be quick for smaller datasets but can take a while with huge amounts of information. For more complex scenarios where you need to transform your data during the move, ETL processes are your friend. Finally, if you absolutely must minimize downtime, consider dual writing, simultaneously updating both databases until everything's synchronized. Okay, let's talk about a really important part of building reliable applications: our handling and logging. As full-stack developers, we need to be able to track down problems quickly when they arise. There are several popular libraries that can help with this. Winston is a great choice for Node.js apps. Log4j and Logpack are common in Java-based backends. Essentially, we want to wrap potentially problematic code in try-catch blocks and use different logging levels like debug, info, or error so we can control how much information gets logged. Plus, structured logging adds really helpful context to our logs, making it way easier to figure out what's going on. Okay, so let's talk about keeping your applications running smoothly. As a full-stack developer, it's not enough just to build the code. You need to know if things are working correctly and quickly spot any problems. That's where monitoring comes in. We'll be looking at the Prometheus, Grafana, and ELK stack, basically 3 powerful tools that work together to give you real-time insights into your system's performance. Prometheus is like a data collector, constantly gathering metrics from your application and servers. Grafana then takes those raw numbers and turns them into beautiful, easy-to-understand dashboards so you can see what's going on at a glance. And finally, the ELK stack, Elasticsearch, Logstash, and Kibana helps you analyze the logs to understand why something might be happening. It's all about moving from just fixing things when they break to being able to predict and prevent issues before they impact your users. Let's talk about static site generators. They're a really popular way to build modern websites because they offer incredible speed and security. Basically, you write your website content often in Markdown, and the SSG takes that and turns it into ready-to-go HTML files. This means no need for a database or constant server processing, which results in super fast loading times. We'll take a quick look at 3 of the most well-known: Next.js, built on React; Next.js using Vue.js; and Gatsby, also based on React. Each has its strengths, like Next.js offering optional server-side rendering for dynamic content, and Gatsby being fantastic for sites packed with information. Okay, let's talk about Jamstack. It's a really popular approach for full-stack developers these days. Basically, it's all about building websites that are super fast, secure, and easy to manage. Instead of traditional apps where everything runs on the server, Jamstack uses pre-built static files like HTML, CSS, and JavaScript, which are delivered directly from a content delivery network, or CDN. This means lightning-fast loading times for your users. We also use serverless functions to handle any dynamic content that needs to be generated on the fly. Think of it as a way to build modern web applications without all the complexity. Okay, so let's talk about how Agile and Scrum can really help you as a full-stack developer. Basically, Agile is all about being flexible, embracing changes as they come up, and always working closely with the customer to make sure you're building what they actually need. Scrum is a specific way of doing Agile, using short cycles called sprints, where you'll have daily stand-ups to check in and keep things moving forward. You've got your product owner who knows exactly what needs to be built, a Scrum Master guiding the process, and then the development team, that's you and your fellow builders actually doing the work. And at the heart of it all is the sprint, which is like a mini project with clear goals and regular checkpoints. Okay, let's talk about how we make sure our code is solid and reliable. When it comes to full-stack development, a good code review process is absolutely essential. We want to look for things like readability, making sure the code is easy to understand, and that variable names are descriptive. Then we need to check functionality. Does the code actually do what it's supposed to? Security is another big one. We have to actively look for potential vulnerabilities. And finally, we're aiming for maintainability, writing code that's neat, modular, and well documented so future developers, including ourselves, can easily work with it. Now let's talk about how continuous integration fits in. Basically, whenever someone commits changes to our codebase, the CI system kicks into action. It automatically builds the project, runs tests, both unit tests and integration tests, and also checks for things like security issues using static analysis tools. If something goes wrong during the build or testing process, the developers get notified immediately, allowing them to fix problems quickly before they make it into production. Okay, let's talk about something really important: protecting user data. As full-stack developers, we're often dealing with personal information, and it's absolutely vital that we understand the rules around it. We're primarily talking about GDPR, which is all about safeguarding the data of people in Europe, and HIPAA, which specifically protects sensitive health information. While they have different focuses, there's a lot of overlap. Both emphasize keeping things secure, being open with users about how their data is used, and giving them control over their information. Okay, so let's talk about webhooks and callback API. They're key for building really dynamic full-stack apps. Think of a webhook as a notification system. When something important happens on another service, like a payment being made or someone signing up for your newsletter, that service automatically sends an HTTP request to **** server. It's called push because the data is actively sent to you. On the other hand, a callback API is more of a check-in system. Your server regularly goes out and asks, is there anything new from a third-party service? It's like periodically querying for updates. For example, when someone buys something on an e-commerce site, the payment gateway might send a webhook to your server, or you could use a callback API to get notified of new subscribers through an email marketing service. Okay, let's talk about optimizing how your website delivers content. As a full-stack developer, you'll want to understand cloud storage and CDN. They're game changers for performance. Think of cloud storage like a giant, super reliable warehouse, and the cloud companies like AWS or Google Cloud offer these services. Instead of keeping all your images and other static files on your main server, you store them there. Now, a CDN is basically a network of servers spread out around the world. When someone visits your website, the CDN delivers those files from the closest server to that person's location, which means much faster loading times for everyone. They work hand in hand. Cloud storage holds everything, and the CDN makes sure it gets to people quickly. Okay, let's dive into adding those super useful real-time elements to your full-stack apps. Things like instant notifications and live updates are becoming expected by users. To pull this off, we've got a few key tools in our arsenal. WebSockets. These create a persistent connection, letting data flow both ways between the client and server. Server-sent events offer a simpler way for the server to push updates to the client. And then there's Firebase Real-Time Database or Cloud File Store, which are fantastic managed services that handle the synchronization automatically. Keep in mind though, polling constantly checking for changes can be inefficient if not done carefully. Thinking about scalability and making sure everything stays consistent is really important when you're building these features. Okay, let's talk about feature flags and rollouts. They're super important tools for us as full-stack developers when deploying new features. Think of them like a switch that lets you turn a feature on or off in production without needing to deploy new code. This means we can deploy unfinished stuff, test with smaller groups of users, and even quickly disable something if it's causing problems, all without having to roll back the entire deployment. We have a few different rollout strategies like percentage rollouts, where we gradually show the feature to more and more users, or user segment rollouts, targeting specific groups for testing. It's all about controlling risk and delivering value safely. Okay, let's talk about protecting our API. As full-stack developers, we need to think about how to handle lots of requests, and that's where rate limiting and throttling come in. Rate limiting simply puts a cap on how many requests a user or client can make within a set period. Think of it like a club with a limited capacity. Then there's throttling, which is even more proactive. It slows down individual clients who are pushing the limits after they've already hit the rate limit. There are different techniques to achieve this, things like token buckets and leaky buckets, each with its own strengths. It really depends on your API needs. Do you have any questions about how we can make our API more robust? Okay, let's talk about multi-tenancy, a really important concept for full-stack developers, especially when building applications that need to scale. Essentially, it means multiple customers are sharing the same underlying application and infrastructure. Think of it like an apartment building where everyone shares the walls and common areas, but each tenant has their own private unit. We need to make sure data is completely isolated so one tenant can't see another's information. That's a big priority. There are a few ways to handle this architecturally, from sharing schemas and databases with row-level security, all the way to using entirely separate databases for each customer. It's a balancing act between complexity and performance as your application grows. Okay, let's talk about making your apps accessible to the entire world. When we build full-stack applications, it's great to think about localization and internationalization, often shortened to E18 and L10. Internationalization is all about designing your app from the ground up so that you can easily add support for different languages later on, no massive code changes needed. Localization then takes this a step further, actually adapting an already internationalized app for a specific language and culture. This means things like translating text, adjusting how dates and numbers are displayed based on the region, and even considering cultural nuances. When building, always keep in mind languages that read left to right versus right to left, different date formats around the globe, varying number formatting rules, and making sure you're using UTF-8 for character encoding to support all sorts of characters correctly. Okay, let's talk about making our web apps super speedy. As full-stack developers, we need to think about performance. That's where tools like Lighthouse and JMeter come in. Lighthouse is a really handy auditing tool built into Chrome DevTools. It automatically checks things like loading speed and identifies areas for improvement. It gives you clear recommendations on how to make your site faster. Now, JMeter is a different beast entirely. It's a performance testing tool that simulates lots of users hitting your application at once. Think about a huge sale online. JMeter helps us see if our servers can handle all those visitors without slowing down. Basically, Lighthouse gives you the quick overview, while JMeter lets us really stress test it and find any weaknesses. Okay, let's talk about DevTools, your best friend when things go wrong. These are built-in tools in most browsers that give you incredible insight into what's happening on your website. We're talking about the ability to inspect HTML elements, see exactly which files are being loaded by the browser, the network tab, and even step through your code line by line with a debugger. Console logging is also super helpful. It's like leaving little notes for yourself as you're coding. Mastering these tools will seriously speed up your debugging process. Let's talk about building solid foundations for our code. As full-stack developers, we're tackling big projects, and writing clean code is absolutely essential. We'll start with a set of principles designed to make your classes more focused and easier to maintain. Think of it like making each piece of the puzzle fit perfectly. Then we'll dive into DIY. Don't repeat yourself. This is all about avoiding redundant code and using reusable components. Finally, keep it simple, stupid. Strive for clarity and avoid unnecessary complexity. Your future self will thank you. Okay, let's talk about design patterns. As full-stack developers, we're constantly tackling complex projects. Design patterns are like reusable blueprints. They help us solve common problems in a smart way. We'll cover some key ones like MVC and MVVM, which separate our code into distinct parts for easier management. Then, we'll look at singleton and factory patterns, useful for handling global resources or creating objects flexibly. It's all about building well-organized, maintainable applications. Okay, let's talk about dependency injection. It's a key idea for building really solid full-stack apps. Basically, instead of a component creating its own dependencies, those dependencies are injected into it. This makes your code much more flexible and easier to test. Think of it like this. You don't build the car yourself, you just get a fully assembled car with all its parts that's in action. We'll look at why it's so important, some common patterns for how it works. Constructor injection is usually the best choice and how it helps make your applications more robust. Okay, let's talk about keeping things synchronized in a distributed system. It's surprisingly important. Basically, every computer in a large network has its own clock, and those clocks don't always tick at the same rate. This is called clock drift, and if you don't address it, you can end up with all sorts of problems, like logs being out of order or transactions getting mixed up. The most popular way to deal with this is using NTP Network Time Protocol, which is a really well-established system for sharing time across the network. For even more precise timing, there's BTP, Precision Time Protocol, which often uses specialized hardware. The best protocol depends on exactly what you need it for. Okay, let's talk about keeping your applications running smoothly, and I mean really smoothly. We've all experienced those frustrating downtime interruptions when our apps go down. As full-stack developers, we want to avoid those at all costs. So, how do we achieve that? Zero downtime deployment is the key. Essentially, it means minimizing or completely eliminating any service interruption during updates. There are a few main strategies like blue/green deployments, where you have two identical environments and roll out changes to one while keeping the other live. Rolling updates gradually replace old instances with new ones, and then there's canary releases, which involve testing changes on a small group of users first before deploying them to everyone. Okay, let's talk about documentation. It's super important for full-stack development. Good documentation really helps everyone on the team understand how things work and makes it easier to keep projects running smoothly. We want to make sure our docs are clear, accurate, and complete. Think of a few key principles: clarity and conciseness. Write in simple terms. Accuracy is essential. Completeness means covering all aspects, and consistency keeps everything uniform. We need to document things like API, system architecture with diagrams, and even the code itself with helpful comments. There are some great tools out there too, like Markdown for writing clearly, static site generators to create beautiful documentation sites, and of course, using Git to track changes along with your code. Okay, let's talk about keeping your code healthy. Technical debt is basically the cost of taking shortcuts in development. It's like accumulating IOU with your codebase. It can slow you down and create more problems than it solves if you ignore it. To manage this, we need to refactor our code regularly. That means making small, manageable changes to improve its structure and readability. We want to focus on the areas that are causing the biggest headaches using the Pareto principle. Think about 20% of your code creating 80% of the issues. And remember, this isn't a one-time fix, it's an ongoing process of identifying, documenting, prioritizing, and then actually tackling the debt. Okay team, let's talk about keeping our web app safe. As full-stack developers, we need to stay ahead of the curve when it comes to security. First up, serverless architectures. They're really popular now, but come with unique challenges around managing permissions and monitoring for anything unusual. Next, zero trust is a big shift. Think about it like this: instead of trusting anyone just because they are *inside our network, we need to verify every single request. Then there's WebAssembly, powerful technology that also introduces new security considerations if we aren't careful. And finally, DevSecOps, integrating security into the whole development process from start to finish is absolutely crucial for building robust and secure applications. Okay, let's dive into some cutting-edge trends for full-stack developers. We're focusing on WebAssembly and edge computing. WebAssembly is essentially a super fast way to run code in your browser. It's like giving your JavaScript a serious speed boost. It allows you to use languages like C++ or Rust, which are often really powerful, directly inside the web browser without needing to rewrite everything in JavaScript. Then we have edge computing. Imagine processing data right on your device instead of sending it all back to a central server. That's what edge computing does. This reduces lag and makes applications feel much more responsive. When you combine these two technologies, WebAssembly with the ability to run at the edge, you get incredibly powerful combinations for building fast, reliable, and engaging user experiences. Thank you for watching.